Hello and welcome to the first in a series of three, hopefully fairly short videos that demonstrate various tips and techniques on how to use QGIS to help with your biodiversity net gain assessments. A little bit about me first. My name's Brian Robinson. I work for ERAP Consultant Ecologists Limited, and we use QGIS to help with our biodiversity net gain assessments as a regular thing now. I think firstly, I really like the QGIS for Ecologists Facebook group that's been set up, and I think we all got into ecology because of a love for nature, and quickly having to learn how to use computers to help us with our reporting and all sorts of other sort of stuff. But computers might not be our first love, so the idea behind the QGIS for Ecologists group, I think, is a really good one. I'm going to assume a working knowledge of QGIS uh, as a first thing. I mean, there's already sort of introductory videos and things up there, so this is going to focus on three techniques that I find really useful with biodiversity net gain. So this first video will show how to get automatically updating area and length calculations to two decimal places, hectares and kilometres. That's the first step, isn't it? And then after the second video, we'll show how to install drop-down lists, so you can use biodiversity net gain habitats and condition assessments as drop-downs. And then from there, you could use the data in the attribute table of QGIS simply to copy and paste it into Excel and use it that way if that's something you're comfortable with. But you can also use the SQL database function in QGIS to help interrogate the data, and that will be the third video. So the third video is sort of optional, I think, but it's not as scary as I thought it would be, the SQL database thing, so it's worth showing. Yeah, a separate point, I am entirely self-taught, so this isn't something that I have learnt on a training course and I'm now disseminating to everyone, because that could be a bit cheeky, but that also might mean that there are better ways of doing things. And if that's the case and you want to tell people about that, please make a video or make a comment and we can always rejig things in the future. So great. So here's a map of the UK using the Every World imagery, and we're going to zoom onto a small part of it to do our example. So using the postcode finder plugin, I have zoomed into Old Trafford ground of the Manchester United Football Club, just because you got to pick somewhere, and I thought this might irritate someone. That's the tall and the short of it. So let's make a new layer. Layer, create layer, new shapefile layer. I'm going to have polygons for this one, and let's have it area habitats. An important point, the coordinate reference system is the British National Grid. If you don't have that as your coordinate reference system, your values are all going to come out really strange. That's the one to use. You can set that as your coordinate reference system to in preferences, so that that's the one that comes up as normal, rather than like either Sodium Mercator. There's any number of coordinate reference systems, but that's the one to use. So then we're also going to make a new field of text data. Out of this, we're going to call that ref. You could call it anything, but it's just something to call our different habitats for the time being. And let's go on OK. So now we've got our area habitats. Let's draw a new polygon. I'm going to use the advanced digitizing plugin because that allows you to make really nice, sharp 90-degree lines. That's our first one. And it didn't ask me, I think I've messed up there. Let's open the attribute table. Yeah, I must have clicked something. So we're going to make a new attribute with ref written on it. I mustn't have clicked something. Right, so Not going well this. Right, there we go. We've got the Old Trafford football pitch. That's not particularly interesting at the moment, so I'm going to add a few things. So I'm going to use a function called the fill ring function, which is really useful. So I can draw another polygon inside the one that exists, call it something else. What should we do to alter? Let's make that salted earth. Yeah, there we go. No, actually, wildflower grassland is better than salted earth. So we're going to turn the picture of Old Trafford into wildflower grassland. What the fill ring function does is it creates a polygon within an existing polygon, but they aren't overlapping. So that's really good when you're trying, as we do in the Biodiversity Net Gain Assessment, trying to make sure that there's no slithers or little polygons or one polygon over the top of the other. Just to demonstrate that, if I delete that, you can see there's nothing behind it. It's not as though this polygon is above that one, separate polygons. And then we're going to split features, because that's also a really good way of drawing a map without creating lots of little slithers and all the rest. What should we have for this bit? Let's have that as a nice swamp. So, very brief, small little example, and now we're going to use the area functions that I talked about at the start. So we're going to open the field calculator. I'm going to create a virtual field. This is important because by creating a virtual field, that field will always update as and when we change the polygon layer. If you just created it as a new field, it would work once, but then wouldn't update. So that's a really useful little box to use. And we're going to call our new field name area. The output field type is a whole number, fine. And then we're going to fill in an expression here to create the ability, so the computer knows that we want it to generate area. Now, if you know what it is, you can just type it in. If you don't know what it is, then you can have a look down the list of things here. I think area will probably be under geometry, and then $area, there we go. And then the output preview shows you what it's going to be. This little box tells you what you've just chosen, so it's all handy. Click on OK, go back to the attribute table, and there we are. We've got our areas all worked out for us. Lovely stuff. Now let's make a few changes. I'm going to put a pond in. Yeah. Fill ring. Not a beautiful thing, but go back to the attribute table, and there we go. Our pond has got an area automatically. So that's grand, but we also, it will be easier for us if we could get QGIS to show us the areas in hectares to 2 decimal places. I'll do this as a series of steps, but you can just do it in one step, if you need to. I just think it's useful to show the steps. So I'm going to open the field calculator again, create a new virtual field, call it hectare. And in this instance, because we're going to go below the decimal place, we're going to use decimal number double for the output field type. And then, as we all know, to get the area in hectares, that's metre squared divided by 10,000. And that's as simple as that is. Once again, it would be better if that could be 2 decimal places, so we'll open the field calculator again. We'll call it something vaguely legible. Hectares to 2 decimal places. Make sure we change that to decimal number double. And then we're going to use the round function to round the value to 2 decimal places. Again, you can type it in if you know it, or you can look on the operators here, and we've got math, that makes sense. and then happily they're in alphabetical order. Round, that makes sense. Again, it's got some information for us here as to how to use it, examples, and I'm just going to type in our area calculation again. That's to give us the hectares, comma, as it suggests here, then we want it to 2 decimal places, and happily that comes up as well, which is useful. Remembering to close the brackets, and the output preview. Okay, so looks like it'll work. And there we have it. So that's our hectares to 2 decimal places. And that's really handy. Now, the length to kilometres is a very similar process, but let's go through it again because there's an outline repetition for learning. So, layer, create layer, new shapefile layer, line, linear habitat, that'll do. Again, make sure it's British National Grid. I'll try and not make the same mistake this time. I think I just forgot to click that. Add to fields list. There we go. Okay, linear habitats. So what should we do to Old Trafford football ground now? I'm going to turn that off. The advanced digitising. Let's have a hedgerow there. Have a tree line there. Let's have a stream here. And then for the sake of weirdness, let's have a fence all the way through it. Obviously, when you're making your maps, you'll make sure that you're not just drawing blank lines and uncoloured polygons. But I think that's to be covered elsewhere. I'm just sticking to the basic principles here. And also, I don't think you need to necessarily save things before you start mucking around with the attribute table. But I'm just in the habit of saving things really regularly with QGIS. Earlier versions used to crash a lot. So yeah, we've looked in the attributes table. There's all our lines. We want the lengths of them to be calculated for us, please. So we open the field calculator, create a virtual field. Let's call that length. Again, whole number. And then if the geometry function has got a $ area, you'd hope that you'd have a $ length as well. And you'd hope that I'd have checked that before I made this video. But here we are. So that will give us our length of each of the linear habitats we've just made. And there we go, that's done it for us. If we update things, let's do that by splitting that one. There you go. So that's worked. And then obviously we want these in kilometres to 2 decimal places. Create virtual field. Kilometres. Again, this is going to be 2 decimal places, so decimal number. That appears to be working on the output preview. And then create virtual field. And one nice way of doing things, you can either try and do things all the way from left to right and hope that it works. If it doesn't, you don't know why it doesn't. Or you can build it up as you go. So I'll assign length, and you can see in the output preview that works. Nails a bit first. I'll assign divided by 1,000 to get kilometres. You can see in the output preview that works, and then round to 2 decimal places. That works. So if you sort of like build it up as you go, that's sometimes easier than doing a big old wedge of coding, if you'd call it that. I don't think it's complicated enough for me to call what I did here coding. I don't know how to do coding. But if you build it up as you go along, then you spot when you make a mistake easier than if you try and do it all in one fell swoop, and then you don't know where you've got to find the thing that's broken in it. So it's okay with that. And there we have it. So hopefully that's useful. Hopefully I haven't waffled too much, and yeah, hopefully the second video is useful as well. Thank you very much. Oh, and yeah, just as a quick point, obviously this information's for free. QGIS is made available for free. If you found it useful, please tell someone who else might find it useful. And if you use it in your professional working life, please feel free to donate to the QGIS project, or, you know, as we're ecologists, the nature conservation charity of your choice. I'd go for Bug Life or the Bat Conservation Trust, but there's many out there. Yeah, and thank you very much again. Take care.